at what happens and go from there. So I think walking through an example, now that you know what RAM is, what is RAM, by the way? Area under the curve using rectangles to approximate that area. More rectangles we have, the closer our approximation is to the actual area under the curve. And that's actually what your calculator does. It does an infinite number of rectangles to find the area under curve. So just a sneak peek. I'm gonna look at number 5. This is in your book, number 5. A particle starts at x equals 0, moves along the x-axis with a velocity of t squared plus 1 for time t is greater than or equal to 0. Where is the particle? And this is kind of like the one we did yesterday, only it was a linear function instead of a quadratic, I think. Where is the particle at time t equals 4? Approximate the area under the curve using 4 rectangles. So we want n. We use n as our number of rectangles. So we're going to say n is 4. Equal width and with heights determined by the midpoints of the intervals. And I think instead of midpoints, I think for this one, we'll do a left and a right and a midpoint so that you can see everything on this. So we'll just walk through this always here. So first, let's think about what this looks like graphically. So parabola, yes, just shifted up once, right? And I'm bigger than 0, so I'm first quadrant only. This is 1. That's my vertex, and then I go up 1 over 1. I probably should have. I'm going to put 1 here. Sorry. Up 1. Remember, I'm going up to 4, right? Because it says it wants to know. Essentially, if I want to know where I am at t, I'm looking for the position at 4, which is the antiderivative of velocity, right? So I'm going backwards here. That's why I'm area under the curve. So I'm just going to graph here from 0 to 4. At 2, I would be 2 squared is 4 plus 1 is 5. Where am I going to be? I'm going to be way up at 4, aren't I? 16, I'll be up at 17. We're going to call that 17. Right? Okay. I'm going to put 17 down some more. Are y'all okay? Just pretend like that's my curve. This will be the point 1, 2. This will be the point 2, 5. This will be the point 3, 10. Y'all see where I'm getting these points? And 4, 17. Because this is velocity. The points are going to be important. That's why I put them on there. Yeah, ready? 417. Oh, yeah. Sorry. Everybody okay? All right. So let's look first if I were to do, we'll do left RAM first. So I'm going to start on the very first endpoint, which remember here I'm going from 0 to 4, right? That's my domain here. So I'm going to start at 0. Now, first of all, it told me 4 rectangles, and I'm 4 rectangles of equal width. So what's the width of each rectangle going to be if I'm going from 0 to 4 with 4 rectangles? 1. Each one's a width of 1. Do we all agree with that? Are we all okay? If I have 4 rectangles and I'm going from 0 to 4, so what you can do is you can do, if it's not quite so even, to find our width, we can do right endpoint minus left endpoint divided by n, which is your number of intervals, right? I want 4 equal intervals. So 4 minus 0 would be 4. Divided by 4 would give me 1. That tells me the width of each rectangle is going to be 1. Is everybody okay there? Okay. Because I'm doing left RAM, that means I need to start at the left endpoint first to make my rectangle. So what I'm going to do is I'm going to start at this left endpoint, and I'm going to come straight across from here until I go across 1 unit, because that's my width, and then come down. So there's rectangle number 1. Rectangle number 2 is going to start on the left side of the rectangle again. Come down. It's going to go straight across until I'm at the end of that interval. Does this make sense? How I'm coming up with left endpoint here. Again, left, straight across and down. Left, straight across. Yeah. This is just remember my drawing is not quite accurate. So this is going to be an underestimate of what I need, right? Because if you were to shade all this in, right, I've got these little triangles here that are left out of the area, but that's okay because this is an approximation. The more rectangles I had, the closer it would be. Can you guess what a right RAM is going to be? An overestimate, that's right. Because if I go from the right and over, it's going to give me too much area. But that's okay. All right. Are we all okay on setting up our rectangles for left RAM? Good? All right. Now it's easy. Now all I have to do is find the area of each rectangle, and then I'm just going to add them all together. Okay? So I'm going to find the area here, and the area here, and the area here, and the area here. Now whenever I do this, how do you find the area of a rectangle? Length times width. Width is constant on all of these. Do you agree? It's the same all the time. So what I'm going to do is I'm just going to do the width, and I'm going to multiply it by, and then I'm just going to add up the heights of each one of these rectangles. Does that make sense to you if I do that? Instead of length times width plus length times width plus length times width plus length times width, I'll just do width on the outside and multiply it by all the lengths added together. Make sense? If you don't understand, you can do each one individually and it's okay. All right, so the first one, what's the height of this first rectangle? 1. Do you agree? So this one has a height of 1. What about the height of this one? Where are y'all getting these values? The y value, that's exactly right. What's the height of this one? 5. And the height of the last one? Yeah. The width of each one is 1. Y'all okay there? 3, 8, 18. So 1 times 18. So I'm going to say that S of, what was it? S of 4 is approximately 18. Whatever my units are for this one. I don't know if it told me. It didn't. Does that make sense? Okay. Change it to right endpoints. See how it's different. If I do the right endpoints, this time I started the endpoint, but I go over that width. Okay, so that width was 1, so I'm going to go over 1, and this time this is the side of my first rectangle. So I'm going to go, instead of going right, I'm going left, back over. So this is my first rectangle. Here's my second rectangle. Third rectangle. So it spans, it goes from the right side of the interval that you're looking at. And then, of course, this one up here. There's my fourth rectangle. Width is still the same, right? And I still find the area of a rectangle the exact same way. Length times width or width times height, whatever. It's easier to say height on here because of how we're looking at it. But my width is still 1. I'll say approximately. And now my heights. So my height here, what's the height of the first rectangle? Now it's 2. What about the second rectangle? 5. Next one, 10. And the last one, 17 this time. So now my height is 2, 5, 10, 7. See the difference? Let's see. Should be a bigger number because it should be an overestimate this time instead of an underestimate. Let's see. 1734. It's a big difference, right? But if I made this 8 intervals instead of 4 intervals, they would be closer to the same number because they would be closer approximations. All right, you ready for the hard one? Yeah. 34. Well, depending on which one they ask you. If they ask you to find left RAM, the answer would be 18. If they ask you to find right RAM, the answer would be 34. But what the problem actually asks you to find is the mid RAM, the midpoint RAM. And we haven't talked a lot about that, and I know we haven't talked a lot about any of them, but this is probably the most common one just because probably the most accurate. It's also the most aggravating one. So here's what MRAM does. MRAM goes to the midpoint of each subinterval, and that's the height of your rectangle. Still have 4 rectangles. The width of each rectangle is still exactly the same, but this time, to judge on my height, I'm going to come, instead of from 0 to 1, I'm going to use halfway between that, so 1/2, and that's going to be the height of my rectangle. So there's the first midpoint RAM. Second one, again, from the midpoint, so this was 1.5. This would be 2.5. Remember, the width is still the same, and I'm going the same, up to 2.5. So here's my next rectangle. Okay, let me draw it over here. So yep. All right, so I got, this is 0, 1. 1, 2, 3. All right, 1, this went up to 17. It wasn't accurate at all. 417. I'm going to take this one off and put it down a little lower. 1 was 2. 2 was 5. Here we go. Okay. My widths are still the same. I'm still doing widths of 1. I just need to know how high up my rectangle goes. So instead of using a left endpoint or a right endpoint, what I'm going to do is I'm going to go halfway between the first subinterval. So halfway between 0 and 1 would be 1/2, right? So I'm going to let this be 1/2. I'm going to come up on the curve. This is the point, 1/2. I don't know. I got to plug it in. This is why it gets sticky. What's my squared plus 1? So 1/4 plus 1. What is it? 1.25. Everybody okay with that? See where I got that point? That's going to be the top of my rectangle. So now I'm going to draw a rectangle that spans this interval like this. Same thing for my next one. Between 1 and 2, is 1.5, right? Okay. Well, that's your, yeah. So I found the midpoint, but I still want my subinterval to have a width of 1. So instead of using the left point and spanning the interval, or using the right point and spanning the interval, I use the middle and span the interval. It would just go to 1. Because my interval, if there's 4 equal subintervals, there's 4 rectangles, then it has to go from 0 to 1. Because my whole length is 4, right? Look at the next one. 1.5 is in the middle. Agree or disagree? Okay. So I'm going to put that point on my graph here, right here. That is the point 1.5. Has anybody done it yet? 3.25. That, remember that equation is x squared plus 1. That's your velocity equation. Ooh, no. Yes, so I'm just plugging the x value in to find the corresponding y value. That's the height of my rectangle now. So it's going to span across. And now here's this. Remember, before I was having rectangles that were giving me an overestimate of the area or an underestimate of the area, but this is almost cutting the difference here because it's over here, but it's under here. All right, how about the next? And once you get the hang of it, you don't even have to draw the pictures anymore because it becomes, you start to see how it works. 2.5, right? This is 2.5, and what, has anybody done that one? 7.25, thank you. And again, here is my rectangle. Then the last rectangle, I'm going to go from 3.5, halfway between. Here's the point. Thank you. And here's my rectangle. Does that make sense? I did all that, one, to show you how the rectangles work, but two, I needed those y values. Why did I need those y values? Those are the heights of the rectangles. So the height of this first one is what? 1.25. What's the width? Still 1. It's always 1. It's always going to be 1. No matter where I put the height of the rectangle, the width is going to be 1. How about the height of this one? 3.25. How about the height of this one? 7.25. And the last one, now I have everything I need to find the area of each rectangle and add them together. So the area, or S of 4, remember we're multiplying by 1, that's just because the width is 1. Okay. So SO4, would you get approximately what? 25. Everybody get it? Does everybody see what we did here? No, let me show you something to make it. Well, most of these are going to be non-calculator, but you do have some that are harder that are going to be calculator. And if you've got the newer calculators, I've got to borrow one of yours, type it in, and then transfer it to everybody. And I'll do that whenever y'all start work. I found a cord, but it'll only go between two new ones, not a new to an old. This is super cool though. So if you already have the program on your calculator, you can do it with me. If not, it's okay. It's no big deal. I'll get it on there for you. Clear out of it and hit program. Is it there? Is it there? Okay. Hopefully it'll work. Try it whenever we do this one and make sure that it works. All right. So if you go into and type in that equation that we were using. What was it? X squared plus 1. X squared plus 1. You don't have to graph it. You don't have to do anything else. Just literally type it in Y1. And then hit program and execute RAM and enter. The number of intervals. How many intervals did we say we were going to use? 4. So I hit 4. Left endpoint. Remember it said we wanted the area under the curve from what to what? 0 to 4. So left endpoint is going to be 0. Right endpoint is going to be 4. And all of a sudden, it's going to calculate the left RAM, the right RAM, and the midpoint RAM for me. Isn't that cool? You don't have it on there yet. I haven't put it on yours, remember? Yeah. I gotta type it in one of those and then send it to everybody else's. Y'all don't have it yet, but I'm fixing. This is what I was typing before whenever I thought I had it on one of my calculators. But I'll get it on there for you. I mean, unless y'all just want to type it in there. But I had to type all this in. Yeah, that's what took me so long, getting ready for y'all to. I thought it was somebody cleared out all my calculators, and so I don't have any of my programs. I'm gonna have to hand type all of them back on me. It's okay. So anyway, but isn't that cool? Isn't that cool how it calculates it for you? So you can see too the more intervals I get, and I could play around with this one and say, okay, well, what happens if I make the number of intervals instead of 4? What if I do 16? And I'm still going from 0 to 4. The numbers are a lot closer to each other now, right? Because I'm decreasing my amount of overage or underage here. So they're getting closer to the actual area. And you can go, I mean, the calculator can handle as many sub intervals as you need to do. I could do 150. Do what? Do 1. I'm going to assume the actual area under this curve is 25. Let's do, you said 1 from 0 to 4. Huge difference. You okay? You understand what we're... Okay. All right, I'm going to get that typed in just a second. Let's see what else I need to type before I switch it loose. I think that might be enough to get you started. I really would like to do a... Let's just practice with that one. Let's do... And I'm going to let y'all get started while I start typing in this program. 283... We're going to go 1 through 14. We've done several of these, but once you hit 7, they're all calculator. So 1 through 6 are the only by hand. And 1 through 3 are shapes, rectangles, and they're not anything bad.